multidisciplinary. They're not the exclusive province of any single discipline or profession. Thus, problems are inherently messy. I've offered a simplistic equation here to illustrate what we mean when we talk about a problem. And by and large, we're looking at something that is the difference between what is ideal and what is achievable. Now, for the purpose of this forum, naturally, our focus tends to be on the technical, shall we say. But I might suggest that this can extend through all walks of life in many different ways and dimensions. And let me offer, at this time, perhaps a political perspective on that. I heard politics defined recently as the art of the possible. So I think that represents somewhere between the ideal and the achievable. Having said that, there are a variety of different ways to look at problems and to deal with them to varying degrees. We talked about solving them, and of course, in the most basic way, as we think of it, that's to find an answer or an explanation. But if we look at the term resolve, that essentially, for purposes of our discussion here this evening, represents containing the problem within acceptable limits. I think we've all dealt with that in one way or another. We could also consider dissolving a problem, which essentially means lowering or redefining the importance of the problem. And lastly, we might consider a problem to be absolved in the sense that we come to the recognition that P may never vanish. It may wax and wane at best or grow worse over time. So in other words, we've made peace with having to manage the problem. So, simply put, exercises are well structured or idealized problems where P equals 0, or the ideal equals the achievable. Let me turn it back over to Debbie at this time.
Wait a second. This one's still yours, I think.
Oh, excuse me. You're quite right. My mistake. All right. So let me go on a little bit further and look at some of the error types that are that may be part of what we deal with. I've offered here a couple of definitions. Again, on the technical side, given the nature of our discussion here tonight. And Webster gives us this definition here that an error represents the difference between an observed or calculated value and a true value. And I think we've heard some of that already this evening. Error also is a variation in measurements, calculations or observations of quantity due to mistakes or uncontrollable factors. Having said that, you'll notice that error types 1 and 2 listed here are probably very familiar to most of us here, if not all of us, and statisticians in particular. And it reflects kind of the common challenge of statistical significance, which traces back to the measurements and metrics that we've been describing this evening. A couple of other different dimensions of error are explored in the book that I've referenced here entitled Dirty Rotten Strategies by Mitroff and Silvers. This is something new out of Stanford University Press. And they elaborate on error types 3 and 4 rather than getting into a lot of that. We might suggest that unintentionally solving the wrong problem is characterized by lazy thinking, and intentionally solving the wrong problem might be characterized as dishonest. And I think we can probably point to examples of that in ways maybe within our technical realm, but certainly outside in the world around us. So now let me turn it back.
Thank you. So, how do you define a problem? That's kind of a key thing. And in my work, anybody who walks in the door has a problem. And we have to figure out how to define it before we can decide what we're going to do to try to solve it. And when people walk in my door and say, why did it fail? Let's say it broke. What's the answer? There's a simple answer that applies every time.
I was waiting for somebody to say that.
Got some smart Alex here. Well, one slightly more technical answer is the stress exceeded the strength. Okay? Are we done? Okay, that'll be $250, please. You know, so at that level, we have the answer, but they probably want to know a little more than that. And so how do you define that level at which you're going to answer or address the problem? How do you figure out what level is useful to those who have the problem? Many people call and they say, well, we want the root cause, whatever that is. But of course, they only want to pay you to find one of the little blue factors circulating in the outer satellites there. But they want you to figure out what the root cause is. Well, they say they want you to figure out what the root cause is, but in fact, they don't want you to figure out what the root cause is, because in order to figure out what the root cause is, you kind of have to look in the mirror, and that's kind of painful, and people don't usually like to do that. So that's the challenge in problem definition. And so when we do this 4-day program that we're anticipating, we plan to spend the first half of the day on problem solving and problem definition, looking at how to define problems. So how do you get people to realize that if they don't address more than just a few physical factors, that these problems are going to come back? Whatever the problem is, it's going to come back. It may or may not be recognizable, but it's going to come back. And of course, we can blame anybody we want for our economic situation, but at some point, maybe we have experienced enough pain that we are willing to start doing something about our contribution to our lazy thinking and large-scale lazy thinking, which in that diagram shows up as latent causes. So, the one point that we really wanted to make is there are a lot of people out there who have some kind of problem-solving methodology, 5 whys, whatever it is. And they think that they can solve any technical problem by going through those tools, right? We'll do an FMEA, and we'll figure out this, that, and the other thing. But do they have a subject matter expert? Do they listen to the subject matter expert if they have one? Often they don't. I have been called in to many failure investigations that were a big problem for a heat treating issue. Did they ever have a metallurgist look at their FMEA? It was a heat treated part. Hello? Would it be nice to have somebody who knew something about heat treating look that over? Maybe? So no method will work if you don't have the right subject matter experts. And no method will create a solution that lasts if you don't bother to understand and take to heart the answers that are provided by the subject matter expert. Whoops. Okay. So, one of the little key things that I hope you will walk out with tonight is whenever you have a problem, there are 2 ways you can look at the problem. You can look at the problem, which most of us don't do. We've forgotten how to do that. We get in front of a problem and we immediately start looking for what it could be. We go down some checklist that's in our mind, or we go down a checklist on a piece of paper or on a computer screen. And that's good, it's useful. That's what we're trained to do, to see